Okay, so what we're going to do today is continue talking about present worth analysis, and the assignment that goes with this is due on Friday. So you need to take what you're learning in today's in-class exercise and combine it with the stuff that we did on Monday and have that submitted to Blackboard before class on Friday. And then next week we have our first exam. So I'll give you some additional details about that test on Friday and on Monday. Maybe we'll have a little bit of review for the test. But I wanted to make you aware of those are the things that are on the horizon. So today we're going to continue with present worth analysis. And who can remember what's the difference between the present worth method and present worth analysis? Like, why do we distinguish between those two things? Present worth method is just when we're finding the present worth of a cash flow diagram. But what's present worth analysis? Yeah.
Whenever we're given a scenario and we have to find which one's better.
Okay, so he said we need to find which one's better. So the analysis is then when we're making a decision with the data. So we found the present value and now we're choosing among alternatives. So this analysis is the key is we're applying the present worth method to choose something. Last time we talked about LCM. So that acronym LCM, does anybody remember what LCM stands for? Least common multiple. Right. And so what the LCM method does is it allows us to overcome a problem with having cash flow diagrams with a different useful life. So this presents a problem. If we have a different study period, we can't compare the two. And so we have to have some way to overcome the different study period. I don't know if this group got any, right? None yet? All right, let's get it up here. And then we can send it around a second time till you're all good and sugared up. All right. So what did LCM do to overcome the study period dilemma? What was the approach, the technique? What did we do?
Make it the same time period.
Make it the same time period how? It's not the same, so we make it the same. How do we do it?
Basically repeat it.
You repeat it. So option A, we'd have 3 cycles of option A, 2 cycles of option B, and now the study period ends at 18 years. Okay? So that was least common multiple approach. In contract services, what we do is we say, one of them is too short. Let's somehow find a way to extend the short cash flow diagram so that it's the same duration for each. And so the one that's too short, look at what we're doing. We're extending it by renting some equipment for 3 years. And we assume that we can go out and lease the equipment. It looks like in this hypothetical example, this equipment can be leased for $4,000 a year rather than buying it again. If you lease it for $4,000, then you're getting the revenue of $5,000 each year, and then you're doing it until the 9th year so that our study period is the same for both options. So remember the problem, the underlying problem is the study periods aren't the same between option A and option B. LCM made the study period the same with cycling. Contract services extends the short one by assuming that you're going to go rent or lease the equipment rather than buying it. So they now have the same useful life and we can compare them. Why can't we compare them if they don't have the same useful life? It's because money in different times has different value just because of how many years it has to be discounted. So if you have the cash flow is only in a 6-year period, it's not just the amounts, but it's also the time frame of those amounts that has to be considered. Okay, early termination, what it does is it takes the cash flow diagram that is too long and it shortens it. So in early termination, what we're doing is we're saying option B is too long. So instead of lengthening option A, let's make option B shorter. And the way that you do that is you sell the item early. And so rather than just using it until it wears out, or its normal horizon here is 9 years. So if the item is going to last for 9 years, let's just use it for 6 years, and then you'll notice that instead of receiving revenue for years 7, 8, and 9, we just take whatever residual equipment value there is and sell it. So just to emphasize here, this green arrow is not the present value of this revenue. The green arrow represents the resale value or the secondary market value for whatever the equipment is. And that may be completely different from the present worth of these future revenues. So these 3 years here, we didn't discount them to year 6. This green arrow is just, you'd go find similar equipment that's 6 years old and find out what is it selling for, and then you'd assume that you sell the item in the 6th year. So now they both have 6 years of operation. The study period is the same length, and we can find the present value of each and find out which option is better. What's the decision criteria for present worth analysis? How do you know whether to choose one option versus the other option, assuming that it's mutually exclusive? What's the decision criteria?
What offers the most profit or the least loss?
Okay, so you want the one that's most profitable.
Yeah.
Good. And how do you know which one that is? Yes?
You take all the values from in the present, compare them to what you paid, like how it compares what the cost that you paid for versus what you're getting back.
Okay, so you take all of the revenues in the future to the present, you combine it with what was already at the present, meaning presumably the initial expense of buying the equipment. What interest rate do you discount everything at? The problem will tell you the percentage, but what do we call the interest rate that we're discounting at in the present worth method? It has a 4-letter acronym. MAR, minimum attractive rate of return. So you discount at the MAR. And so the decision criteria, just to sum it all up, is you choose the alternative with the highest positive present worth. If neither of the alternatives have a positive present worth when discounted at the MAR, then reject them both and instead choose the do-nothing alternative. Okay. So any questions about contract services or early termination? All right, so we sell the equipment early. Here is today's in-class exercise. I have 2 problems for you. On the front side of the paper is a contract services problem. On the back side of the paper is an early termination problem. And so you're going to get some additional practice with each of these techniques to combine with what we've already done using LCM. So I've given you the factor tables for this one. So you should do it pen and paper, or I guess pencil and paper. It doesn't have to be pen. But the point is we're not doing these ones with Excel. You should do these ones using the 4% table on the front and the 10% table on the back. Okay, so this cash flow diagram, there's going to be multiple steps for option A. If you think about the pseudocode or kind of like the structure of the solution, there's going to be find P given A. And so this is one continuous annual series up top of the revenue. And then this annual series, we can't get to year 0 in a single step. There's first of all going to be the step of consolidating an annual series into a single amount. And so find P given A will take it all to year 6. And then we have to do find P given F to get it from 6 to year 0. So it's a multi-step process, whereas option B is relatively simple. So here's how we're calculating option A. There's the $11,500 that's a cost already at the present, and then the $5,000 in annual revenue taken to the present by multiplying it by the P/A factor, and then subtract, because it's a cost, the $4,000, and you'll notice I just multiplied these two factors together sequentially. There's the P/A factor, which gets it to year 6, and then the P/F factor gets it from 6 to year 0. So in the end, if you keep all the precision in your calculator till the very end, you're going to get 16,903.85. But you'll notice that I rounded the number to 16,900. Now the reason for that is with the factors that we've got, that's all the accuracy that we can predict, since one of these factors was only 4 digits long. So the P/F factor that I used, on the table it only says 7903. So that's 1, 2, 3, 4 digits of precision, which means that I have to round this off to 1, 2, 3, 4 digits, the nearest $10. And so I round down $903 to the nearest 10, rounds down to 900. So 16,900 is the answer if I'm using the factor table that only has 4 digits for one of those numbers. Any questions about option A and the process that we followed to take everything to the present? It takes practice to know what steps to do. It doesn't just come immediately. It takes the practice of the homework assignments and doing the in-class exercises. I sometimes worry when I see someone just copying down the solution to the in-class exercise, because you're not learning if you just copy down the numbers that you see on the screen. It's like figuring it out on your own or talking to your classmate during the kind of free unstructured time. That's when the real learning happens. The learning isn't just having the solution on paper, it's figuring it out. For option B, this is an easier one. We just have to find the present value of the annual series and combine it with the cost that was already at year 0. So again, I rounded off. This time, the factors that I have, there's 1, 2, 3, 4, 5 digits in that factor. So assuming that this is exactly 16,200 in cost, then combined with the result of this revenue taken to the present, then I can report option B to the nearest dollar, because that's 1, 2, 3, 4, 5 digits. And we learned that option A is better. Of the two options, I would rather have 16,900 instead of 14,285. And what do these numbers represent? That represents the value of the cash flow diagram when it's discounted at 4%. So if you borrowed money from the bank to make this project happen, and you have to pay the bank 4%, then this is the present value of the profits you get to keep after paying back the bank their share. Now, after covering the principal and the interest that's going to be due to the bank, then the present value of your profits that you get to keep is 16,900, assuming you go with option A. So the decision criteria is when the cash flows are discounted to the present at the MAR. That's kind of a summary of what the present worth method is. And then the decision is, among alternatives, choose the alternative with the highest non-negative present worth. So both of these had a non-negative present worth. They both have positive present worths. And we choose the one that's the highest, so present worth of option A. All right, so on the next problem, we have a cash flow diagram that we are going to terminate early. And so we want to make option B shorter rather than lengthening option A. So once you've done these calculations, I'm going to be circulating around with the answer. I think some of you maybe already have it done. Let me check your answer. If you got it right, then that's it for today. You can go ahead and leave early. Otherwise, I'm going to stick around and continue to help and answer questions. But for those of you who do leave early, just remember that the homework is available now, and it's due by Friday. All right, so let's be working on this one, and don't leave until I've seen your solution. If you want to double check the numbers, they're up on the screen here.